we don't really hear much from our lecturers. We sit in lectures and learn stuff that we need to learn to pass the exams and get a physics degree, but trying to hear about what they actually do in academia is really important, I think, because the stuff that they're learning in research actively is influencing what we learn in lectures. So it's really important. And also it's just so interesting, and it's great because hopefully it should infuse those students who are thinking of going into research, perhaps who haven't made up their minds yet, that actually there's a whole world out there of research that they can contribute to as well.
Okay, so who's knowingly looked in the sky and seen a planet? Jupiter or Venus or Mars or something? Quite a large number. Okay? So that's great. You and I can see such a planet by eye. It just looks like a little speck of light. We know that if we go and get a telescope and go and look hard, we can learn a lot of stuff about it. But if we really want to get some useful information, we need to send a rocket out, a probe of some sort. Okay? Now imagine doing the same thing, but now not one of our planets, but a planet going around another star, however many light years away. It seems to me still remarkable that you can tell that there's a planet there at all. But that's old hat. Old news. What's new now, and what's new in the past few weeks and months, which David's been working on, is the following. Imagine, here's the star, here's the planet, and you can tell that you've got a planet in front of the star. One of the main techniques is that the planet comes in front of the star and blocks some of the light. So if you just monitor the intensity of the light, it will just dip down like that. And you can learn a lot from that transit technique when the planet transits in front of the star. So that allows us to determine things like the mass of the planet, how far away from its parent star it is, and we can learn a lot of useful things from that. Here's the thing that David's been doing, which I find quite mind-blowing. He's not just looking at the change in intensity. Here's the star out over here somewhere, here's the planet coming along. You look at the way, not just the light is reduced by this planet coming in front, you look at the spectrum of the starlight and you look at see how the spectrum is different when the planet is in front or not. Why might it be different? It's easy to see why it might drop. Why might it be different? Yeah.
Atmosphere.
Yeah, good. How?
Because it has different types of gases in it which then absorb and then re-emit.
Yep, brilliant. But think about how amazing it is. How thin is the atmosphere around the Earth compared to the size of the Earth? It's close to nothing. It's vital, you know, you and I wouldn't be here without it, but it's very, very small. And yet that small amount of atmosphere going in front of the star will change the spectrum.
The main research areas that we have here are astrophysics, which we haven't covered, but also the biophotonics and electromagnetism. Eros deals with quantum systems and nanomaterials, and Professor Winlove is the biophysics side of things. So I really wanted to choose those lecturers because they're so enthusiastic and clear and eloquent in the way that they describe their research, but also they love their subject, and you can just tell by the way that they move around and their eyes light up when they're talking about it. And I just wanted the students to see that kind of enthusiasm and passion about knowledge, about the pursuit of knowledge which goes on at university. So this is why I wanted to set it up really. And also it's nice to get the students talking to the lecturers about their research and having these kind of events to kind of facilitate that learning. I just